Alright, in this video we're going to talk about the average value of a function and how we calculate the average value of a function. You may say, I know how to calculate an average. Well, it's a little bit different when we're dealing with calculus and some continuous functions, things that don't necessarily happen before you get to calculus. So let's look at this average daily temperature. The graph below records the temperature throughout one day in Celsius with time in hours after midnight. Answer the questions below. So this is, what is the average rate of change of the temperature from midnight to noon? Well, let's look at midnight, which would be right here, and noon would be right about here. At midnight, the temperature, so at 0 the temperature was 15, and at noon it looks like the temperature was about 23. So if we want to know the average rate of change, that's just a slope. It's the slope of this line between those 2 points. So that would be 23 minus 15 over 12 minus 0. 23 minus 15 is 8 over 12. So 8 over 12 degrees per hour. That's the average rate of change, degrees per hour. 8 over 12 degrees per hour is the average rate of change. So now it asks us to estimate the average temperature for the entire day. Well, there's a low of 15 and a high up here, maybe of 24. So I suppose we could go halfway in between there, but it looks like we're up a little closer to the high point most of the time. At the end of the day, we ended up maybe about 21 or 22. So to just take the average of the high and the low point doesn't really work that well. So let's just kind of, it looks like maybe that average, what if I did about 21? I did about 21. That'd be a little lower than that, the 20 or 21, somewhere in there. Okay, so how about 20 to 21 degrees? And again, we're just estimating, just thinking what we think the average might be for the day. So let's talk about average value of a function and how we would calculate it. We know that we add it up. Well, that's what an integral does. An integral adds things up. If I wanted to add these temperatures up, I'd have to have all the temperatures. And since temperature is continuous, so we always have a temperature. You're never without a temperature. So we'd have to know the temperature at every second, every millisecond in order to do that, but that's obviously not something we're going to do. So what we would do is we're going to add it up like an integral. The integrals function where we take the area under the curve, and that's how we would add them up. So the average value of a function on an interval, okay, on an interval AB is given by FAV, or F average is what that really says, 1 over B minus A times the integral from A to B f of x dx. So this, add them up, that's what that does. Add them up just like we do when we take an average, and that's really divide by how many they are, okay, which we've done for many years. So let's look at an example of how we would use that then. Okay, find the average value of the function f of x equals sine of x on the interval 4 to 7. So I would have the average would equal 1 over 7 minus 4, the integral of 4 to 7, sine of x dx. And we put that in our calculator and let our calculator do the work. That would be negative 0.469. Now if we don't have our calculator, we can still do it. It'd be 1 over 3, and then we would take the antiderivative here. The antiderivative of sine is negative cosine of x. This is non-calculator. Evaluated from 4 to 7. So I would have 1/3 and then negative cosine of 7 minus negative cosine of 4 And if we're doing non-calculator, actually this answer would be acceptable, because we could put that into any scientific calculator and get that answer. As long as we can put it into a scientific calculator and get an answer, that would be acceptable. They do not expect us to know necessarily the cosine of 7 and the cosine of 4 in this case. They would use more things like pi and 0 if they were doing it, but on a non-calculator, this answer is okay. That answer is okay for the AP test. Alright, so this is our calculator version and our non-calculator version. Alright. The graph below shows the velocity v of t of a car in kilometers per hour over the first 8 seconds of a drive. Okay. What does the integral expression 1 over 8, 0.8 v of t dt represent? They will almost certainly do this to you. And as soon as you see that 1 over something, 1 over 8, 1 over 10, 1 over 12, whatever it is, you should suspect average value. 1 over 8 with an integral after it. Okay, well, this represents the average velocity of the car during these 8 seconds. And they want us to use a trapezoid sum to estimate. Okay, well, if I'm going to, just got 4 subintervals, so I'm going to go from 0 to 2. There's one trapezoid. It actually is a triangle at first. Then I'm going to go to 6, 4, and then to 6, and then to 8. There's our 4 trapezoids. So our first one, 1/2 times 2. And since all of them are 1/2 times 2, I'm actually going to do it separately, but we'd have our first trapezoid would be 0 would be the height 1 plus, looks like maybe about 25 would be height 2, plus 1/2 times 2. Of course, you could do the 1/2 times 2 at once if you wanted to. And then it would be 25 plus, then that'd be 35. Plus 1/2 times 2 again, and then 35 plus at 6 it looks like it's not quite, maybe 43. Let's make it 43. Plus 1/2 times 2, and then 43 again, plus, and that height looks like it's maybe 51. Make it 52. Okay, how's that? 51, 52. It really doesn't matter. So these cancel. These cancel. 1/2 times 2 is just 1. So I've got 25 plus 25 and 35 makes 60. Plus 35 and 43 makes 78. Plus 43 and 52 make 95. Add those up. Okay. So 25 and 95 make 120. 180 plus 78 is 258. Now we have to do 1/8 of 258, and actually with non-calculator we could leave it that way. Just make it 258 over 8 would be the average value, and that would be accepted. That would be 32.25. Okay. So the average is about 32.25 velocity, so kilometers per hour. That would be the average velocity. Okay, they also may ask you to do this with a table where you would have to calculate it with your trapezoid sum from the table, which is very likely because then they can give you exact numbers so that you're not guessing any numbers and they don't have to give a range of values. Good.